Happy Monday, everybody. Welcome in. We are on week 5. We're going to spend a couple days on something called functions. This is one of, in my opinion, the most important weeks for this semester because it's going to help us out with a majority of the midterm and the final questions. The questions will be write a function that does something. Right? That's going to be most of it. All right. And by the way, for folks on the recording, I'm using my laptop mic, so there's going to be a slight degradation in audio. But yeah, please let me know on the recording if I need to re-record anything. All right. Let's jump into functions. Just to kind of motivate things a bit. Remember the robot cat? Our first assignment? All right, a robot cat looked like over here. Right, this was the very first assignment we did. Wouldn't it be cool if we could do this in like 10 lines? Remember, folks might have done this in like maybe more than 50 lines, maybe some probably did it in 100 lines. With functions, we can reduce this to like about 10 function calls. So there's like 10 shapes here, right? There's this big square, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right, there's 10 shapes in here. It's possible to draw the robot cat with 10 function calls. So yeah, we need to talk about functions in order to do that, right? That's just kind of motivating it a bit. All right, what's a function? Right, so we're going to be loading up these two things right here, the function lessons, right? And then along with the lab. So I'm just going to load both of them up. Let's see. But, before we even jump into this, I want to give folks a sneak peek. Right, so let's not do the lesson yet. I'm just going to load up a blank notebook and kind of give a sneak peek on what we're looking at. Okay, so I'm going to make a brand new notebook. And I'm just going to call it a functions sneak peek. All right. This is going to be pretty cool stuff. We can think of functions as Legos. We're going to build Legos and then use them to put them together. Right? We're going to put the Legos together. So, let's kind of talk about what functions are. Right? In the very beginning of class, we might have been introduced to something called the print function. Right, so this is a function, meaning that inside of these parentheses, it takes an input. It can take an input. Right? So if I put hello in here, right, this gives us hello. Right? This is a function that takes an input and it does something for us. Right? So in this case, we're using the Lego print to do something. Now, we also got introduced to another function called a length. Right? This is a function that takes an input of something. Right? I could just put hello in here again, and it's gonna give us something. It's gonna give us 5. Right? The result of this returns 5. Right? So input hello, output is 5. All right. So just kind of bringing functions up. Right? There's tons of functions we can use, right? And you can actually look this stuff up too. If you type in something like Python built-in functions, right, some of them are here. So I'm just going to look at the primary documentation. Right, we've used length. Let's see, and a few more. Let's see, which one else do we use? Oh yeah, format. I think we used that too. Wait, no. We didn't exactly use this because it was a class function. So we'll talk about that in a bit. This is a little different. Let's see. I know we use another one. Oh, we use type right here. This is a function that takes some sort of thing in the input and it describes what it is. All right. What other functions? Let's see. Oh yeah, and in the print too. All right, so tons of them. Earlier, Terrence brought up something about format. We actually I don't think we've used this yet. We've used a class version of this. So just to kind of to talk about what I'm saying, right? So these are called classless functions. Right? So this is a classless function. This will make sense in a bit. Right? So and then this one is also a classless function. Right? Earlier, Terrence was talking about something called like a dot format, like you might have seen something called some string dot something, right? Like I think we saw string dot capitalize. I think we've seen this a while ago. All right, and in this case, if I put hello space world, right, this is a class function that capitalizes the very first word. Right, so this is a class function. Right, it's a class function. You can think of it as a dot function, meaning that the string has a function called capitalize. Right, and then we've seen another class function called format. Right, so if I did like hello and then dot format, right, this is another class function where we put in something in here. Like I'm just gonna put something. Right, so this one gives us the string hello something. Right? So this is a class function. It's different from what we saw up here in the built-in functions. This one does something a little different. You can click on it and see what it does. But yeah, it's different from the string version. So this week we're gonna focus on classless functions. These first two, right? Meaning they're not dot functions. They're some name and then some input in here, right? Some optional input. Right? We're not going to be focusing on class functions, so I'm going to delete these. Right? These are dot functions. All right, so let's focus on these classless ones. All right, like let me just make another cell. Wouldn't it be cool if we could have access to a function called greet? All right, so this, if I were to run this function, right, this imaginary function, it says greet is not defined. This makes sense because this doesn't exist in the Python kernel yet, but we can go ahead and make it exist. Right? This is like building a Lego. Right? So we need to build a Lego that we can use. One way we can do that is by saying define this function, right? And we're calling it greet. Right? So this is saying define a function, and then colon, and anything that's underneath it with an indent will be part of that function. So I know I'm saying function a lot. We're going to see what it means in just a bit. Right? So if I were to put like hello world, right, and then another one in here, print how are you? Right, we have two print statements within a function. Right? So let's go ahead and run this and see what happens. Okay, so I press the play button. Nothing happened. Right? Nothing got outputted actually, but something did happen. The kernel, the Python kernel, now has access to a Lego piece called greet. We can do something called invoke. Right? We can invoke the Lego piece by just saying greet right here. Right? Greet with two parentheses. Right? This will invoke the function, meaning use the Lego that we just built. Right, so just to kind of put some terminology up here, this is called defining a function, right? And this is called invoking or calling a function, right? So we can call it multiple times, right? The cool thing about defining this Lego, we can call it, we can reuse it, right? That's a very good thing about functions. We can reuse it over and over again. Right, so I just called greet 4 times, and if we run it, right, it does it 4 times. Right, pretty cool, right? Okay, let me bring it back to 1 though. So hopefully people kind of see what we're doing. Wouldn't it be also cool if we could change this function and have it greet different people? Like, if I were to invoke the function with a string like Bob, right? And let's say we wanted to say, hello, Bob, how are you? Right? But, this is not going to run, right? It's saying greet takes 0 positional arguments, but 1 was given. This is saying that the function that we defined has nothing in the parentheses, right? There's no input here. But when we called it with 1 input. So yeah, it's saying that this doesn't match the definition, right? So we could modify this definition to take an input. And so the way we do that is by putting a variable name here, right? It doesn't matter what we put here as long as there's some text, right? So I'm gonna put name in here, right? Meaning that when we call the function with this string, the string will be substituted into this variable, meaning that we can go ahead and use it within the string. Right, so I'm going to use it within the string, turn it into an f string. Right, so this means Bob will go into name, and then name will get substituted down here. Okay, so let's test this out. Right, I need to rerun this definition, by the way, right? Because we just changed the function. So let's rerun this cell. Okay, there it is. I just reran this cell, and now we can invoke the function. And we're going to end up with, hello, Bob, how are you? Right, because we called this Lego, right? Bob gets substituted up here. Right, and we can do that again, right? We can reuse functions, like say greet Alice, right? And run it and says, hello, Alice, how are you? And we can keep spamming it over and over again. Greet Charlie. Right, hello, Charlie, how are you? So we're reusing this. People cool with this so far? Pretty sweet, right? Okay. Let's see. This might be going a bit ahead, but one of the common misconceptions here is this variable here, right? This variable name. Right, I do want to say that this is a general variable that hasn't been defined yet, right? It only gets defined when we call the function here, right? So we call it here, and then this gets substituted into here. And so the reason why this is a misconception is because some folks might hard code the name, right? They might say name is equal to Bob, all right? And this is a pitfall, because if we were to hard code the name to be Bob, it means that anytime we call the function, it'll always say hello, Bob. Right? This is it's a very common pitfall, right? The reason why is because we call Alice here, right? We call greet with Alice, but then Alice gets substituted into here, right? And then immediately it gets overwritten into Bob. So this is called hard coding, right? This is a very common issue that we'll see a lot. Anyways, I'm going to delete this. This way it'll actually print what we need. Okay, I see a hand up. Let's see, Lisa, yes.
Yeah, hi, Andrew. Sometimes you're really clear, and then other times it's like really jumbled up. I'm not sure why.
Mm-hmm. Oh, okay, so the mic quality is bad, huh?
Yeah, but it's like sometimes you come in really clear, and then other times it's like really hard to hear you. So.
Okay. Thanks for letting me know. Let me change my sensitivity. Distorted. Okay.
Right there is good.
Okay, hold up. Let me just change something. My external mic broke, so I'm using the laptop mic.
Right. Like right now, I can hear you really good.
Okay. Yeah, unfortunately, this might happen frequently.
Yeah.
If worst comes to worst, I'm gonna re-record this at home. I have a much better setup at home.
Thank you.
Yeah. Testing. Okay. Yeah, but please let me know in the Zoom chat again if things are distorted. It got worse. Oh, okay. All right. It's looking like I'm gonna have to re-record this at home. Okay. For folks on Zoom, would you be okay with waiting like a few 4 hours? I gotta go home and re-record this. But yeah, if anything is disordered, then yeah, just wait for the recording. I'm gonna do this over again. Yeah, what's up? Oh yeah. Okay. But yeah, folks on Zoom, my bad for the technical issues. I don't know why my mic broke, but yeah, are people okay with that? I'll just re-record this at home. Okay. But for the folks in, you sound good now? Okay, cool. It's probably gonna happen again. Yeah, so I'm gonna, yeah, I'll re-record it. But yeah, for the folks in person, you should be good. Yeah. Okay, so yeah, for folks on Zoom, feel free to stick around. If things are distorted, yeah, there's going to be a higher quality video around tonight. But yeah, thanks for letting me know. All right. Let's see. We just got a sneak peek into functions. We built a Lego and then used it over and over again. So let's move on to the lesson. All right, we're gonna probably do the first piece of it and then move on to the lab. We can think of a function as a black box that groups together instructions, right? And we give them a name. So the name is whatever we define the function as, and it contains instructions that are inside of it. All right, so let's do this with a turtle. All right, this is the part where we're gonna see how the robot cat can be done in 10 function calls. So this is a function called triangle. Right? We're going to define this. Right, so in this case, we should probably, let's see. Let's go ahead and define a function called triangle. All right, this means, yeah, it's a Lego piece called triangle. And I'll put together some instructions in here, right? Like what instructions produce a triangle? It's 3 moves and turns. All right, so in this case, it's gonna be TU. Yes, it's these 3 over here. All right, 3 sets of moves and turns. And then there is a comment here, right, that this is documenting what the function does. Right, we'll see more on this later, but typically functions have a documentation that tells the user how to use the function. And so there's 3 moves and turns here. That should make a triangle. All right, and when we run the cell, right, once again, it doesn't do anything, but the kernel did load something. Right? The kernel now has access to a function called triangle. We can go ahead and use that. Right? So let's invoke the function. Right? So we can invoke the function by just saying triangle, right, with 2 parentheses. All right. This is going to give us an error because it goes to the function and it says TU is not defined. Right? This makes sense because we never created a new turtle instance. Right, so once again, we call this function. It goes up to here, right? And then on the very first instruction, it failed because tu was never defined. So we should probably define it, right? Like over here, maybe do a tu.new, right? But before we even use that, we have to import. All right, so I'm gonna go ahead and import it. Jupyter turtle.turtle as tu. Right. So now when we run this, we see a triangle. All right, people see what's happening here. We created a turtle, and we invoked the function. Right, so this is invoking the function we defined earlier. Now let's go ahead and invoke it again. All right, so if I were to spam this over and over again, all right, let's see what happens. Okay, it just looks like a thicker triangle. Right, but there are 3 triangles. They're just overlapping. Right, but if we were to move it around a bit, like triangle and then tu.move, and maybe let's move it like 100. All right, let's just move it a bunch. All right, then we should see triangles on different areas. Right, and it looks like the 3rd triangle is off the arena. But yeah, there are 3 triangles. It's just that our arena size is too small. Alright, people cool with this so far? So yeah, hopefully people can kind of get a sneak peek in how to do the robot cat in different function calls. So let's move down a bit. The indentation inside of a function does matter. All right, so up here we define the function with 4 spaces. All right, this is important in Python. If it weren't for the spaces, right, like if these were to not be indented, then whoops. If these were not indented, then that means the function only has 1 instruction. All right, so please be careful with indentation. So I'm going to tab those. Okay. Yeah, indentation matters, and this is the anatomy of a function. Okay, so let's go ahead and do some more. Let's see. Folks on Zoom, is it still coming out distorted? I think the recording should be good though. Sounds good? Okay. Another example of a function right here, right? Once again, the name doesn't matter, right? In this case, we just called the function my function, right? And we have a documentation here that kind of just describes what it does. Okay, so here it's just going to define 2 variables, and then we're just going to print it. Right? This is just a hard-coded function that always prints hello world. And so run this. So this gets here. You know what? Let me play this tiny bit at a time. I need to edit this cell. Editable. Okay, let's run through this a little slower. So let's run this right here. We see no output, right? Even though there is a print statement. Right? That this makes sense because we never invoked the function yet. Right? We defined it, so we have access to it. So we could go ahead and print it right here, right? My function. Right, this will properly invoke the function. So you're going to see this a lot. Right, invokes the function. Right, so now it should print hello world, right? Because it's calling the instructions inside of here. And then that the order does matter. If we print something before, it should print it before that. All right. Hopefully people are cool with this so far. Yeah, this is some really useful stuff. Okay, and once again, the indentation does matter. All right, like if this were not indented, then these are technically not part of the function. They're statements being executed outside of it. All right. All right, we saw a sneak peek into something called arguments. It's another way of saying inputs. Right, like if we were to define a function called say hello, right? This is just like the greet function that we did earlier. Earlier we did a greet function in the sneak peek over here, greet name. Right, same thing. In this case, we're going to define the function as having an input. Oh, hang on. I think I did a keyboard shortcut that made it read only. Okay. Okay, say hello. Cool. So say hello. We're going to define it as having a variable called name. All right, once again, this variable won't be defined until we invoke it. All right, so this is kind of like a blank name right now. All right, so we're printing an f string that says hello and then a name, right, an f string. So I'll run this cell. Right, once again, it doesn't do anything. This is just a template. It's a cookie cutter that we should probably use. All right, so let's go ahead and invoke it in the next cell. So say hello, and then we can put a string in here, like Bob. Right. The second we invoke this, Bob will be substituted into this name, and then also substituted into this f string. Right, so this should just print hello Bob. And once again, the cool thing about functions is we can reuse it with different arguments. Right, I could put Andrew and then Charlie. Right, we're calling the function 3 different times, and the substitutions go as we want. Okay. I do want to reiterate the misconception earlier, where some folks might hard code this argument here. Right, this input is called name. Right, some folks might do this. They'll say, "Oh, name is equal to Bob." Right, once again, you don't want to do this because it's forcing the function to always say Bob. Right, meaning that these substitutions will be overwritten. Right, so if I were to run this function again, right, so brand new function, and if I were to call these 3 with 3 different arguments, it's always going to say hello Bob. Right, this is a very common pitfall that I see. So, it should have printed hello Andrew, right? But Andrew gets substituted into name, right? But then this next piece, it overwrites it, right? It says, hey, name is now equal to Bob. Right, so that people see why this is always printing hello Bob, because the misconception here is we're hard coding function arguments. Right, this is a pitfall. Right, pitfall. So I'm gonna go ahead and comment. Actually, I'm just gonna delete this. Right. Okay. So yeah, we should be good. And there we go. Are people cool with function arguments so far? All right. Let's do a couple more and move on to the lab. We should be able to do the first 3 questions in the lab, just a bit. Okay. A function can have multiple arguments. Right, so we've seen functions with 0. Right, so over here, this is a function with 0 arguments. Right, 0. There's no inputs within these parentheses. Right, when we call it, there's no inputs. We've also seen functions with 1 input, like down here, right? Say hello. Right, we define the function with 1 input called name, and when we called it, right, it has the input right there. We can have 2 inputs as well, right? Like if we were to write this function right here, right, it has 2 arguments, first name and last name, but we can assume that these are strings. Right, so let's go ahead and define this name tag. Right, don't forget the colon. And there's 2. One is the first name, and next is the last name. Once again, these are empty for now, right? They won't be initialized until we invoke the function. So let's just keep it simple. Let's just do 1 print statement in here that just prints the first and last name. hello, my name is first name and then last name in period. Okay, cool. So let's run this. Let's run it. Okay, once again, it didn't produce any output, but we did define a Lego piece that we can call down here. All right, so let's call it. So name tag, and it requires 2 arguments, right? 2 inputs. So let's go ahead and put in 2 different strings here. All right, so I'm just gonna put my name and another one, tac. All right, name tag Andrew Tac. So this should say, hello, my name is Andrew Tac. All right, and we can do another name too. All right, we can reuse the function, just put a different one, like Mike, and then Matera. Okay. People cool. People cool with this so far. All right. Okay. Let's move on then. Okay. Let's move on. If we were to upgrade the triangle function by adding another argument, we could do that. Our earlier triangle function took 0 arguments. So just scrolling up a bit, we wrote a triangle function here that was hard-coded. Hard-coded means that it's always going to produce the same result. Right? In this case, it's always going to make a triangle that's 70 pixels on each length. Right? But we can add in another argument, right, that controls the size of it. So let's write a new triangle function. We'll go ahead and upgrade it so we can control its size. So there's going to be some pretty cool stuff. Right? This is the part where folks might see how to do the robot cat. So I'll define a brand new triangle function. Right. So this is going to take 1 argument. I'll call it size. We can assume that this is going to be some number. And I'm just going to document this. Right. We'll see this in a bit, but it's good programming practice to document the function, meaning explain what it does. Right. This way, if a user were to ask how it works, then they can just look at the documentation. So I'm just going to say this draws a triangle of specified size. All right, once again, size is not initialized until we call it. All right, so let's go ahead and do tu.move and size. All right, we don't know what the size is yet, but we'll know in just a bit. And I'm going to hard code this 120 here. Right, hard code means that the triangle will always be equilateral. Equilateral means it's each of the angles are the same. And then let's go size again. tu.turn 120, and then tu.move size again and turn. This way it goes back to its original position. Okay. So now we have a function. Let's run it. Okay, it didn't do anything yet, right? Because we need to invoke the triangle function. So let's go ahead and invoke it. So I'll go triangle, and then it does take 1 argument, right? A specified size. Right, so I could put in some number here, like let's go 20. Right, the second we play this function, 20 will get substituted into here, right? And then it will substitute into the rest of these sizes. So let's run this. So press play, and oh, you know what? Okay, it didn't do anything, because we didn't do a tu.new. Right? It actually did show it in the arena above here. So earlier we had a arena somewhere up here. Right? It did do it, but we can't see it. So let's redeclare our a turtle here. This way we can see it. Okay, so tu.new, and then there we go, triangle. And so there is a triangle here. Let's make it bigger. All right, so I'll make it like 40 now. All right, 40, and then run it, and we see it got bigger. And we can keep controlling it. Let's go 80, and run it. There we go. See? Pretty sick, right? And once again, we can move the turtle around. Right, like maybe if we were to move it, like let's say tu dot. Let's turn it like negative 90 degrees. This way it's facing right, and then let's move it a bit. Tu dot move. Let's go 100. Okay, there we go. So we drew triangle, moved it over here, and let's draw another triangle. All right, triangle of let's go 200 this time. Very big triangle. Run it. Okay.
So with the scale above that, is that just an example cell? Like, is that like, are the measurements running out of, is the turtle running out of that cell right now, or do you just place those numbers?
Oh, the turtle is running out of this cell.
That cell right there?
Yeah, because we did a tu.new here.
Yeah, so why is this telling me that the turtle object has no attribute with triangle in quotations? It's saying the triangle is an attribute.
Let me see. It might be a typo. Let me see real quick. Oh yeah, because so it's not a class function. So we just go. It's not tu.triangle. It's just triangle.
Oh, shit.
Yeah. Yeah, that's a good thing. Thanks for bringing that up, Terrace. Yeah, so earlier someone had written this as a class function, meaning that if we were to do a tu.triangle, this is technically invalid because this is kind of calling a class function. We're not talking about class functions yet, so this is going to give some error. But we're dealing with plain functions that are not dot functions.
Somebody just vocalize a triangle. We just listing just a function, not a class function. So triangle is the function right now.
Mm-hmm.
So it was circle, like circle would be a function.
Exactly.
Okay.
Yeah, and square. Okay. This is kind of a good sneak peek into the next assignment. Right, the next assignment was published earlier. It's the same thing as the first one, right? Robot cat. Right, so our next assignment will be draw robot cat, but with functions. So hopefully people can see how this can make the drawing a little more cleaner. Okay. All right, let's do one more example and then move on to the lab. All right, we should have enough to do the first 3 in the lab. Last week we talked about HTML, so we might as well apply that. All right, I'm just gonna import the HTML library. This way we can display things. Okay, let's say we have a function called nameTag again. Right, this is gonna be the same as over here. All right, so earlier we wrote this function nameTag that takes a first name and a last name. All right, let's do the same exact thing but a little fancier, right? In HTML instead. Okay. So I'm going to define a function. Let me zoom in a bit. Call it HTML nameTag. Right, in this case, let's give it a couple arguments, right? Like, let's allow the user to change the text and the color. So in this case, I'll call it like text and then color. Right, or actually, let's go name. These don't matter, but they do help with readability. All right. Last week, we might have seen HTML strings, right? Like if we were to define an HTML string called myHTML, right? Like I'm just gonna call this myHTML. This is a string. Let me make it a multi-line string. This way we can see things a little easier. All right, multi-line string meaning we'll use triple quotes. All right, let's say we want the HTML to represent the name using a specified color. All right, so here let's start simple. All right, let's only focus on the name for now. Right, like let's say the HTML string just says hello, I'm a name. All right, but name is gonna be interpolated. So make sure to make this an F string. So I kind of just snuck in this F, but this is so we can substitute name into here. Okay, so we defined an HTML string, right? Let's say this function will display it as well. So I'll call it HTML and then my HTML, and then display it. Okay, so far this function, it creates a string and then displays it. So let's test it. So I'll press play. All right, there we go. We defined it. Now we need to invoke it. So I'm gonna make another cell and invoke it. All right, it's called HTML name tag. It takes 2 arguments. All right, so I'm just gonna say Andrew, and I'm gonna put in green for now. All right, the green won't matter yet because our function currently only cares about the name. All right, so if I were to run this cell, it's gonna say hello, I'm Andrew. Right, and you can keep changing it like Charlie, and hello, I'm Charlie. All right, Bob. All right, let's start simple. We want this HTML string to have control over the color. All right, well, one way we can do that is by using this style attribute. All right, meaning that we can wrap it in some tags. All right, like let's say I have a tag like a h1 tag. All right, h1 is a header. Let me format this. And then close it off with another h1 tag. All right, so once again, this doesn't have the color yet. All right, if I were to run this, it's just gonna print it bigger. All right, hello, I'm Bob. All right, that's what the header does. We can specify the color by adding in this style attribute. We saw this last week, right? The one way we can do it is say style is equal to some string. Right, so style is equal to some string, and then yeah, that's it. And the string here would be represented as here, right? Color, and then colon, and then the value of what we want. Right, in this case, we're just going to interpolate this variable here. Right, so color is equal to whatever we invoked it with. All right, let's test it. Okay, there we go. I just ran this function, and now we can test it with green. All right, there we go. So hello, I'm Bob, and it's in green. All right, so 2 things happened here. Right, we invoked the function, and these arguments got substituted into here. And so we can call this over and over again. Like, let me go Andrew, and then red. And then let's go Mike and make it blue. And so run it, and now we invoked the function 3 different times. Pretty sick, right? Okay. Oh yeah. Let's take a look. You might have to rerun the function, so.
Invalid syntax.
Oh yeah, yeah. So you gotta rerun this now. Yeah, this makes sense because it's spelled so name tag with an E.
Put a G.
Yeah, yeah. There you go.
It is. So the function to change the color.
Yeah, the second argument is actually supposed to be color.
The second argument.
Yeah. So here, you mind pasting it up here actually? This way we can see. Just go down a bit. Because we got it wrong, so yeah, just cut this.
Oh, this is supposed to be here.
Yeah. Oh no, I'll keep that. Yeah, yeah. Because you're gonna replace it with something else. Yeah, yeah. But then this second argument is actually color because it gets substituted into here.
This one right here.
Yeah.
So should I put it up there or put it in that cell? Do I put the color? Do I put the color inside?
Oh, in here because it's gonna get substituted over here.
So literally put the color on.
Mm-hmm. Yep. Yeah. Yeah, because if you put it in here, it's gonna force it to always be green.
Right here we're telling it that we want it to be a color.
Yeah.
Okay, gotcha.
Exactly. All right. Thanks for waiting, folks. Just had to debug a few things. Okay. We just went over the basics of functions. We should be able to do the first 3 questions in the lab. All right, so let's move on to it. Let's go to the lab over here. All right, we should be able to do part 1, 1, 2, and 3. Right, so they're going to be a tiny bit tricky because we haven't really covered math yet, but we'll give it a try. We'll give it 15 minutes. And if folks aren't sure how to do these, we're going to go over it together. Right, so don't worry. But yeah, 1, 2, and 3. Not number 4 yet, because we haven't really covered return values. Okay, yeah, give it a shot. We'll give it like 10, 15 minutes. Okay, welcome back, folks. Let's do the first 3 parts of this together. First 3 questions, I mean. I realized that the instructions might have been a little confusing. So let's clarify what these instructions mean. So when it says write a function called foo, right? This means right away we should be able to define a function called foo. Right, so the function name doesn't matter, but this question wants it to be called foo. Right, and then next it says takes one argument called bar. Right, these are just random names for it. But in this case, we want the input to be called bar. Alright, so there we go. We finished this first part. Right, write a function called foo that takes one argument bar. Right, and then the body of the function should print the contents of bar. So this is pretty cool because so really what we're doing is a wrapper for the print function. Right? All we're doing is rewriting the print function, or actually wrapping it. Right? So this function should print the contents of bar. Right? So that's all we need right here. Right? So anything that we specify will just be printed back out. Right? So I'll go ahead and run this. All right, there we go. Let's test it. Right? Meaning that we should invoke the function bar with something. Right? Like if I were to say hello, right? Hello gets substituted into bar, and then the body of the function just prints it. Right, so I'll just print hello, and there it is, prints hello. Right. So it's just a fancy wrapper for the print statement. Hello world, hi. Right, prints all 3 of it. Okay. So yeah, that's really what this instructions mean. I'm sure it's not foo bar. Oh yeah, yeah. Foobar is an analogy for something in programming. Let's see, foobar. This is an analogy. It's foo. It's actually foobar baz, and there's more of it. It's pretty much like saying x and y, right? Like in math, they always use x and y and z. In programming, they typically use foobar baz. Just a general term. Okay, let's see what else. Okay, hope this makes sense. Let's move on to the next one. Okay, this one says write a function called doSum. Right, so right away we should be able to define a function called doSum. Right, in this case, it's going to take two arguments, right, a and b. Right, so two arguments, two inputs, a and then b. Oh, someone in the Zoom chat, Lisa, what does return none mean? Yeah, good question. All right, in the first part, it says returns nothing. You know, we haven't even covered this yet, but some functions have return values, meaning that you can store the value of the function, right? So you can do return something in here, right? But in this case, we're not going to return anything. We'll talk about return statements in just a bit, right? After this, we'll get a sneak peek into it. But basically, returns nothing means that there should be no return statement. Right? All the function does is do something, but it doesn't propagate something back to the user. This will make sense in just a bit. But yeah, a good question, Lisa. Let's talk about return statements. That's actually our next topic. Okay, so doSum. Right, we want to take two arguments, a and b. So there we go. And the body of the function should just print the sum of these two arguments. So we can just go ahead and print the values of these two added together, right? A plus b. Okay, let's test this. So let's run it, and then if I were to invoke the function and test it, right? doSum. Let's test it with some random numbers like 5 and 6, right? 5 and 6 gets substituted into a and b, and we should print out the sum of them. So there we go. We got 11, right? And we can do that over and over again, right? With different numbers. 4 and 6. This should give us 10, right? And then 4 and 66. This should give us 70. Now let's make this function a little fancier, just so the output is more verbose. Right? These can be arguably hard to interpret. So we can just convert this into an F string, so we can visualize what's happening. Right, so we've seen this in the previous couple lessons where we did F strings, but yeah, we can interpolate some variables like turn this into an F string, and then say this is equal to a plus b. Right, and then turn this into interpolation as well. Right, so this means that whenever we print the values, it'll output a plus b is equal to the value of them put together. Right, so that's what this F string is doing. Right, a gets interpolated here, same with b, and along with their sum. Okay. Cool. Hope that makes sense so far. So the majority of the midterm will be questions like this. Right? Write a function called this that takes two arguments, right, or whatever amount of arguments, and then it's going to specify what the function should do. This is the majority of the midterm questions. So yeah, make sure you're comfortable with writing functions. Okay, and then it says returns nothing. All right, we'll talk about that in just a bit. Okay. Finally, number 3. This one, okay, write a function called print repeat. So right away, we should be able to define a function called print repeat. And it takes two arguments. Right? These don't really matter, but it wants us to be called words and then times. Okay, there we go. So the goal of this function is to print this argument a certain amount of times. All right, but basically, here I didn't define it yet. Right? I didn't implement the function yet. But the goal of the function is if we were to call this with like hello and then another number like 5, right? This should print hello 5 times. All right, so once again, hello gets substituted into here, and then 5 gets substituted into here as a number. All right, so let's go ahead and implement this function. All right, we might have seen a while ago that you can multiply a string with an integer. All right, people remember that? So here, just pulling up a terminal real quick. You might have remembered this from like day 3, right? Hello times 5, right? If we multiply a string by a number, right, it gives us another string. So we can take advantage of this string multiplication, right, by printing words times times, and go ahead and wrap that in a print statement. All right, there we go. So let's run this function. Okay, we defined it. Now let's test it. We'll invoke the function here, and we see that it prints hello, hello, hello 5 times. And we can keep trying that over and over again, right? Like if I were to copy and paste this over and over again with different numbers, all right, 1, 2, 3, 4, 5, right? There should be 5 different lines. So I'll run it, and there we go. 1, 2, 3, 4, 5.
Wait, why did you do it like that in the second cell?
Oh, just to call it over and over again.
Okay. Oh, I see.
Yeah. Oh, good question. Someone in the Zoom chat, Joe, what if we don't put a number? Yeah, that's a good question. We should try that, actually. Yeah, what if we don't put a number for times? So here, let's simplify it. All right, so 5. All right, what happens if we go like hello times world? All right, let's see. So I'll play this. It gave us a type error, right? Can't multiply a sequence of non-int of type string. This makes sense. If we were to, it makes sense because we can't multiply a string by another string. That's a unsupported operation in Python. That's what it's saying right here. So if we were to try it plainly, right, like hello times world, right? So let's see what this gives us. Right, it's the same exact error message. Can't multiply a sequence of type string. So that's the same thing as here. Yeah, good question. Okay. Yeah, it seems problematic if you don't know what the function is doing. Yeah, so we'll talk about documentation in a bit, but typically we have something called a docstring, right, which tells the user what the function is supposed to do. Right, so we'll talk about this in a bit, right? But typically we would tell the user that the arguments, right, consists of words, which is a string to repeat. And then we'll talk about the next one, times. All right, this is an integer, right? A number that represents the repetition. So, this docstring is actually pretty cool, right? So if I run this, right, do people remember this from day 3 or week 1 or 2? There was a function called help, right? The help tells us how to use a function. So if we were to say, hey, give me help on print repeat, all right, let's see what it does. So help on print repeat gives us the docstring. It says, hey, this is how we use the function, right? The first input is a string, and the second input is a number. So yeah, this is documentation, and you can actually see this. Oh yeah, cool. Yeah, thanks. Yeah, cool stuff. And you'll see this in the documentation too, right? Like if you were to look up some Python functions, like let me just look up some class functions or methods. Right? The string methods in Python, these are not class functions. I mean, not non-classless. These are class functions. But typically, if you were to look at documentation, it would tell how to use it. Like okay, it doesn't say what type it tells you to use it, but typically they do specify.
Is that?
Oh, just documentation, Python docs.
Could you go to number 2? I almost got the last one. I just missed.
Oh, sure, yeah, number 2, right here.
Oh, the quotation. Okay, got it.
Yep. Okay. All right. Hopefully this was informative. Okay. We just finished the first 3 numbers, first 3 problems here. Let's talk about return statements. Folks might be wondering, oh, what's return here mean? Right. Well, here, let's take a sneak peek. Right? This is actually the next part of the lesson. So let's take a sneak peek. I'm gonna open up this blank notebook that we had in the very beginning of class. And here, let's start over. All right, let's. You remember the print function? Right, print like hello. Right, all this does is print hello. Let's see if it's returning something. Right. Well, does this function give us a value? Well, let's see. Now, let me just say something is equal to print hello. Right. This is saying print hello might give us something that will be stored into here. All right, so let's see. So I just ran this cell, right? It did print hello, but let's go ahead and see the value of something. So I'm just going to print a value of something is, and then something. All right, let's just see what this is equal to. Okay, let's run it. Okay, value of something is none. Right, so this is saying that this function didn't return anything, right? Because the value of something is none. Right? This is not outputting. It is outputting hello, right? But it's not returning a value for something. Right, so once again, in Python or programming, right, the right side is evaluated, and then it sets it to the left. Okay, let's do this with another example. Right, like remember the length function? Right, like length of hello. Right, so length of hello, right, gives us 5. Right, but what if I were to store it in something? Right, what do you think will happen if I print the value of something? Right, it gives us 5 because the length. This is a function that gets evaluated, and then it returns a number. This number gets stored into the left side, something. And then we end up printing the value of what it returned. Right, pretty cool, right? So that's kind of what return statements do. All right, let's jump into the lesson and do some returns. Okay, so going back to the returns over here, functions. Let's see, let's scroll down. We got all the way to the return values right here. Okay. Let's write a function that gives us a random number. Right? It's pretty much a random number generator. So I'm going to define a function called random number. Right, that takes no arguments. Right, let's just keep it simple for now. Let's define a function called random number, and just to keep it simple, let's just return 4 as always. Right, I'll just return 4. This is not really a random number, but we're going to build upon it. So return 4. Okay, run it. Okay, and now every time we invoke the function, right, random number, right, you see how it produces 4, right? That's because the value of this expression is equal to 4. Right? We can go ahead and assign it to something, right? This doesn't matter, right? So the value of something should always be equal to 4. Value of something is something. You know, let me just use an F string. Okay, so we'll run this, right? Value of something is 4. It's always 4, right? Because this gets evaluated, and then it returns something. Return means that this whole expression will collapse to the return value, right? It'll become 4, right? So this becomes 4, and then something takes upon this value. And that's what's happening here. This whole thing is collapsing. Okay, so let's run it. Right. So this is not really a random number. Right? If I can keep running it over and over again, and it's always going to be 4. Right, so just kind of you don't really have to know how to do this, but there are some libraries in Python that allows people to generate random numbers. Right, so I think the library is called random. Right, I'm just going to use a terminal here just to kind of build upon it. Right, there's a library called random. Right, if folks are wondering what this library is, you can look at the documentation. So Python random. Right, these are class functions. And yeah, it's pretty dense, but in particular, we're going to focus on something called a random int, right? Random integer. So if we were to do something like random.randint and give it 2 arguments, right, like 0 and then 10, right, this should give us some random number between 0 and 10, right? And it can run it over and over again, right? It's just generating random numbers between 0 and 10. So we can use this inside of the function. Okay, so let's go ahead and do that. We need to import a random, and then inside of it, we can say something like generated number is equal to random.randint. 0 and then 10. In this case, I'm just gonna hard code this range and then return the generated number. So let's go ahead and run this. There we go, import. And then now every time we run this cell, it should give us a different number. Right, I'm pressing Control Enter, which is pretty much the play button. Okay, see different numbers. Right, so let's kind of dive down what's happening. Right, so
Just run until like equal up to 10.
it doesn't go up. It's generated a random number.
Oh,
Yeah. Yeah, the reason why is because this library gives us a class function.
so it won't go past 10. It's from 0 to 10.
Exactly. Yeah, it won't go past 10 because we told the function to limit the range.
Gotcha.
Yeah, you can change the range in here too if you want. But yeah, here let's trace this code to see what's happening. Let's see, Joe, is it truly random though? Haha. You know what? Good question. It's kind of random. I think so. There's something called a seed. Right? Typically random number generation uses something called a pseudo random generator, which is something that's kind of predictable. And I think Python uses a pseudo random generator, but as in a seed. Right? A seed means that it'll affect the algorithm to make it less predictable. But yeah, it is not truly random. That's a good question. It's possible to.
What's the weird
Yeah.
pseudo at? Where's pseudo? That's some math again, isn't it?
Pseudo. Let's see. Oh, so someone asked about what does pseudo mean?
That's another term.
Super user, if I remember correctly.
Oh yeah. This is a different type of pseudo.
Oh.
I think Tiris. So there's another type of pseudo. It's called super user do. If you're in a Linux class, then this means give you superpowers. But we're talking about this pseudo right here, which means fake? Okay, yeah, good question. So anyways, let's dive down what's happening in this invocation. Right, so we call this first line. All right, once again, this very first line, the right side is evaluated first. So on the right side, we invoke a function called random number, and we go here, and then generate a random number, and then return it. Right, so this right side collapses into a single value, which is stored into something right here. Okay, hopefully people are cool with that.
Why is this, like, why won't generate a random number? I'm pretty sure it's probably like a typo.
Yeah, let me see. Oh yeah. Look at this.
I wonder if that's it.
That should be it. It works?
Yeah, thanks.
Nice. Okay, cool. Just kind of a sneak peek into return statements. Return technically does two things, right? It quits the function and collapses the function into a single value. Right? So if I were to do something called a premature termination, right? We could do something like this right here. Like, what if I were to return 4 inside of the random number? All right, let's see what this is going to do. So we define the function, right? Return 4. It's not going to do these at all, right? Because this is doing two things, right? It's terminating the function and also collapsing it to a value. Right? So now if we run this here, it's always going to be 4, right? Because the function prematurely terminated, meaning that these next statements never happen. So this is a kind of common. People might be wondering, oh, what's the point of this? Well, later on we're going to learn if statements. So if statements are a way of branching in a program, meaning that we'll do something if something is true. So sometimes it might be necessary to put 2 different return statements in here. Like maybe if some condition is true, then do this one. Else, if some other condition is true, then do this one. So it's necessary to have multiple return statements sometimes. But in this case, we haven't really covered if statements yet. So let's just keep it as a single return. All right, people cool with this so far? Some good old return statements. Okay. Just to reiterate that, the return statements, right? If we were to prematurely return, right? So this function prints something and then returns, right? In this case, it's not returning anything, right? So it's only doing one thing. It's terminating the function and not giving it a value, right? So this is technically returning none. And then it shouldn't get a chance to print this right here. Right? So if I were to call this function early return, right, and then invoke it, it's only going to print, you see this, right? It's not gonna, it's going to terminate here, and this next one never happens. Right? Once again, this is necessary because in the future we're going to do some if statements, right? We're going to do if something. Here, don't type this yet. If something, do this, right? Else, do this. Right, so that's, or like this right here. If something, then do this, and if it doesn't happen, we're gonna go down here. Right, so sometimes it's necessary. Okay, so let's bring it back to normal though. Whoops. Let me redo that. Okay. And once again, this is technically returning nothing. Right, this is the same thing as saying return none. Right, you don't have to do this. It's the same thing. Right, same thing. So I'm going to return nothing. All right. Okay, let's see. Let me see if we have enough to do. Okay, we can return multiple values as well. Like, in this case, this is just a function that returns 3 comma separated strings. So if I were to define this over here, right, that this returns 3 things. So we can go ahead and invoke the function, right? Like maybe we could say something like x, y, and z is equal to multiple values, right? And then I'll just put, oh, this one takes no arguments. So I'll go ahead and run this. Okay, it did do something, right? But it didn't output anything. So let's go ahead and make another cell and just print out what x is. Right, like maybe x is x, and do that with y. Y is y, and then z is z. Alright, so that's all it's doing, right? But pretty much it's possible to return more than one thing, as long as the left side matches up. Okay. All right. Okay, let me look at the lab real quick. We should be able to do the rest of part 1. Right, the rest of it is number 4, 5, and then 6. Yeah, let's try that out. And then part 2, we'll do this on Wednesday. We're going to spend 2 solid days on functions. But yeah, make sure you can do all of this stuff before Wednesday. Okay, let's take an intermission. The rest of part 1 is asking us to implement return values. Okay, a 15-minute intermission. We're doing the rest of part 1, 4, 5, and 6. Okay, welcome back everyone. I'm going to cut the intermission a couple minutes short because we got a few more minutes left in class. So let's do the rest of this together, and then we'll do the part 2 in a couple days. Okay, we went for here. We're practicing return values. Right, write a function called IAM4. Right, so this one we just got to define a function called IAM4. Right, and there we go. Right, there's no arguments, but we do want it to return a single number. Right, just return 4. Right, so that's all it does, and then we can test it out like IAM4. Right, this should evaluate to 4. Right, that's we could store it into some variable too, because typically when we call functions, we're using the result for a future calculation. So it would be good program practice to store it in some variable. This way we can reuse it. We can use that result later. Okay. Okay. The next one, do some return. Right. This is going to be the same as what we did earlier, but in a different style. Right. Earlier in part 1, number 2, we were asked to write do sum, but this one just printed the sum of it. Right, this next one doesn't require a print statement. Right, it wants us to just calculate the sum and return it. Right, so no print statements in here. Okay, so define a function called do sum return. Okay, it takes two arguments, a and b. Right, so these are the two variables that we'll have. And then it needs to return the sum of the two numbers. So we'll go ahead and, a and b here, right? We're going to sum these up, right? You can store it into some result, right? Like the result is equal to a plus b, and then go ahead and return the result. Right, so let's go ahead and test that. So let's test it. We'll say do some return, and then put in some numbers. Right? I see some people putting a and b here. This actually will give you an error because a was never defined. Right? This makes sense because we're expecting a initialization. Right? So we're expecting some numbers here, like 1 and then 5. Right? So then when we put 1 and 5, they will initialize these over here. Right? So do some return, this gives us 6. Right? This is the value of this function. Right? And once again, it's typically good practice to store this result somewhere. Right? This way we can use that calculation in the future. So we could go result or something. Right? Something is equal to do some return, and just go ahead and print it. Right? Once again, we're storing it. Right? So there we go. Same thing. Yeah, we're printing it, and we can change these numbers, and it should change. Right? 3 and 5. Oh, and then Joe in the Zoom chat. Yeah, there is a shortcut way of this right here, right? Basically, you don't have to store it in the result. It's also possible just to return a plus b. It's the same thing. I just feel like this is a little more verbose. But yeah, this is the same. Boom, and then a plus b. But I'm gonna keep it like this. Return result, so it's slightly more readable. Okay, cool. Finally, number 6. Let's see. Write a function called isGreater that takes two arguments called a and b. Okay, this might seem a little hard to read. Let's imagine that we were to invoke the function, and the purpose should make a little more sense. Right? The purpose is if we were to call the function isGreater, and then 50 and then 60, right? This should give us a Boolean value. In this case, it should give us true. Right? It wants us to return true if the second number. Wait, no. It wants. Here, let me read this. The function should return true if a is greater than b. Okay, this should return false. Right? It should return false because this first number is not greater than this. Right, so once again, this is not going to run because we need to define it. Right? So let's go ahead and define it. So define a function called isGreater, right? And then it takes two arguments, a and b. Right? So a and then b. And we want it to return a Boolean value. Right? So one way you could do this is by storing it into a result. Right? Like you could say, hey, is a greater than b? Right? Once again, this is an expression that evaluates to true or false. Right? So you can store it in the result. Well, once again, if folks are wondering why, you might remember this right here, like 10 is greater than 20. Right? This gives us a Boolean value. Right? So this is going to evaluate to a Boolean, and then we can go ahead and return the result. Okay, so let's run this. Okay, and then finally, when we invoke the function, it should give us false. Okay. And you can change the numbers around. Like if I make the 70, it should be true. Okay. Hope people are cool with that so far. We are about 4 minutes overtime in class. So let's close up. We finished about the first half of the functions lesson. This is one of the most important weeks in this course, I believe, because functions is just so popular. Like if you were to get a job in a company that does software engineering, most likely you're going to be writing functions for your coworkers to use. Also, the midterm, it's going to have lots of it. lots of function questions. And the next homework assignment is called Robot Cat. This one was released earlier today. It's the same exact thing as the first project, but hopefully people's code will come out cleaner. Okay, other than that, thank you all for coming, and we'll continue the rest of this in a couple days. And thanks for bearing with the audio issues. I should have my microphone fixed in a couple days. All right, see you all later.
All right, thanks, Andrew.
No.